Today I want to talk about the sample distribution curve. Maybe take some notes on that and also look at the confidence interval. So as we go through, check your notes. I'm going to ask you to stop and add things in if you need to, and I would even try to follow along with the problems. So first off, what is a sample distribution curve? We've looked at two other kinds of curves, the normal curve and standard normal. This is different because this is when I'm dealing with groups. This is key. So if I want to look at, instead of looking at my percentage score, my percentile in a class and a test, I might want to look at actually how my class did overall. What percentile is my class compared to all of the other stats classes? So when I'm looking at a group, the equation changes. I can look at it for a mean, that is a number like my score in a test, okay, or weight or height. And if I do that, this is the equation I use, where n is my group size. And I also could do it for percent. That would be just for like yes, no questions like how many people have a driver's license, the percent of people with a driver's license, they just answer yes, no, or how many people voted for Clinton in the 2016 election. That would be a yes, no question, and you would just come up with a percent. So then I'm using this equation right here. You still have a regular normal curve. The area underneath is still 1. So when we describe the distribution, you probably already know this, but we always write n to let you know it's a normal curve. We put the center in the first part, and then we put the standard deviation. So I'm often going to ask you to describe the distribution, and this is what I'm looking for. So just to really make it clear, the difference between the normal curve and the sample distribution. So a normal curve is looking at one person, where the distribution is looking at a group. So an example would be with pregnancy. So first notice the big difference is simply just that standard deviation. The standard deviation shrinks. It shrinks by the square root of n. And that's because when you look at a group, suddenly all those extreme values that kind of make the standard deviation larger, those extreme values get watered out by the other group members. So your standard deviation is actually tighter. You have a tighter normal curve and a smaller standard deviation here. So if I was looking at pregnancy, for example, I've got how many days a woman is pregnant right here. If I'm just asking the probability that a woman is pregnant longer than 280 days, I'm asking you just about one person about her probability. I'm using a normal curve. But if I'm asking you about a study conducted on 60 women, so now I want to know over on the average of what's happening to 60 women, then I'm going to be using a normal sample distribution. So let's also look at one other thing about sample distributions. You might want to make sure this is in your notes. And this is how that normal curve changes when the sample size increases, right? So when sample size increases, if you look at these two equations, you'll notice that both of these, the standard deviation has n in the denominator. That means that it's shrinking. It's being divided by that square root of n. So yes, you can imagine if you have a normal curve with just a super small sample here, it might look like this, right? But if that n increases, we're dividing a number by a bigger number, and the bigger number you divide it by, well, your answer actually is smaller. So our standard deviation is going to increase. So you'll notice, decrease that is. So as the standard deviation decreases, it's going to be due to that increase in the sample size. Notice the curve's getting narrower. If I increase it even more, my normal curve shrinks even more. So again, you might want to kind of make a note of that, of what happens to our standard deviation when n increases. Now, we've talked a lot about how to find values on a normal curve, specifically with a sample distribution. I just want to go over these steps with you right here. If you haven't put these in your notes and you want to, you can pause the video right now and write these down. What I'd like to do is take all of these steps and go over them with an example. So you can kind of walk through the example, maybe come back and write down these steps, write them down while we're doing the example, or pause and write them down now. All right, so let's look at the example. We've got homes. They have a mean value of 140,000, standard deviation of 60. We're going to look at 100 homes. I'm looking at a group, and I want to see the probability of costing less than 130,000. So here's the steps. First thing I need to do is determine if it's a percent or mean problem. This is about an actual quantity I'm counting, so I'm going to say it is a mean problem. So this is the distribution I'm going to use. Once I've done that, I need to make sure the conditions are met. Is n greater than 30? And yes, n is greater than 30. It is 100. Next thing, I'm going to find the distribution, that is the mean and the standard deviation. Notice the mean is exactly the same, but look at that standard deviation. It's actually smaller, and the reason it's smaller is because I had to take my original standard deviation of 60,000 and divide it by the square root of n. And if you take 60,000 and you divide it by the square root of 100, that is by 10, you get 60. So I have a new standard deviation. Now I can draw my curve. Okay, I'm going to draw it and shade it. I have a curve, nice curve right here. All right, my center at 140. I'm shading it at 130. I wanted the probability to cost less than that. So you can see 130 is marked here. I'm shading to the left because it's costing less. And now I can just use a normal CDF in this case to find that percentile, the probability. So when I do that, you end up with 4.78%. All right, so now let's try to apply this to confidence intervals. Confidence intervals always use sample distributions, and what we're trying to do with a confidence interval is say with confidence where I expect my actual answer to be. So again, I'd like to kind of look at an example. But before that, I need to kind of discuss the two P's. We're going to first focus on confidence intervals for percents. And when I do that, I got two P's. The P we've been dealing with here, and this P is the P for the entire population. We're assuming I know that if I asked, we talked about the number of sea fan coral that are diseased. If I asked that probability, and I'm trying the probability, that is the percent of them that are dying, this P would mean the true percent of all sea fans in all oceans. Hard to get at. So often and pretty much always when doing confidence interval, I'm dealing with P hat. This little hat signifies to me that it is not the entire population, that I've just taken a sample. And I'm trying to predict and infer what's happening for everybody using this sample. So P hat is not going to change the math at all, but it's important I write that so that everybody looking at my research knows that I do have a sample. I'm not looking at every single coral in all oceans. Okay, so the standard deviation here with a P looks like this. The standard deviation with a P hat looks like this. Exactly the same, but I drew little hats, and I actually now call it a standard error. All right, so you might want to put this in your notes so that you remember we're looking at standard error with confidence intervals, and it has to do with samples. Now the steps, I'm going to just put them out really quickly for you right here. Again, you can write these steps down, pause it and write them all down. I'm also going to go through them slowly in an example. So feel free again to pause it and write these 5 steps down for finding a confidence interval. So let's move along with this example. All right, so we're going to look at this study on underage drinking. We've got 200 students, 120 say they drink. Let's find the 95% confidence interval. Okay. Now again, the reason I'm finding a confidence interval is that if I just gave you a single number and said exactly 66.6% students drink underage based on the study, do you think I'm correct that one number represents everything? And I'd probably say probably not. I only looked at 200 students, and there's actually millions of students in the United States. But by giving a range, I can say, but it is probably maybe between 60 and 70%. Now I'm getting more accurate, and by giving you an exact confidence level, I can tell you how certain I am about this measurement. So I'm being in a weird way, even though it's a range, it's actually more precise. All right, so let's look at it. First step, check conditions and find P hat. So I'm going to look at P hat. P hat is in this case like the number of yeses over N. 120 said they drink, so that's 127 yeses. My N is 200. All right, and that gives me 60%. I check my condition to make sure that I can actually use a sampling distribution. Those conditions are that N times P is greater than 10, and N times, let's say 1 minus P is also greater than 10. That is a typo, sorry about that. But when I check both of these, I find out that both 120 and 80, they're both greater than 10. All right, next step, I've got that. Now I need to find the standard error and state the distribution. So to find the standard error, I use the same equation for standard deviation, except for with my P hat, and I get 3.46%. So my new distribution is right here. Next step, I've got my distribution. Now I need to really work towards finding that confidence interval, which means finding the margin of error. That's that plus or minus. You might have heard it before. People will say, oh yeah, last year the average temperature in the winter was about 40 degrees plus or minus 5 degrees. Well, that plus or minus is your margin of error. That's the range we expect it to be below or above. To find it, we need to multiply z, that is how many standard deviations out you want to go. If you want 95% confidence, you go out this many standard deviations. Here's for 99, here's for 90. I would write these down in your notes, make sure you've got these, and you multiply that by the actual value of your standard deviation or your standard error. So we do just that right here, all right, and you get 6.78. So now we can find our actual interval by doing that plus or minus. We add it and we subtract it from our actual P hat. So we do the math right here, and here is your answer. Finally, we can just state our answer. This is the general sentence that you state it with. You might want to write that down in your notes. And here's our final sentence. We are 95% confident that between 53.22% and 67.78% students drink underage. I just again want to see the difference of why we bother with a confidence interval. If I just give you my p-hat and say 60%, that's just one single point, and a single point is actually likely to be wrong, and I also have no idea how likely it is correct. When I give you a range, I'm much more likely to capture the true value, and on top of it, I've given you even more information. The range where the true value lies and the probability that it is correct. So confidence intervals are really powerful tools. You may want to go back through this video to write down your extra notes on steps that you need, and I hope this is helpful. The next thing you want to do once you make sure you have good notes is going to be to move on towards the classwork and homework for today, which is right here.